In this video, we will give a brief overview of the reproducibility study we performed on Greenwood et al.'s 2024 paper, User Item Fairness Trade-offs and Recommendations, and how we extended it. With more information around us nowadays than ever before, recommendation systems have become increasingly present in our everyday lives. However, in every recommendation system, there is an intricate balance. Recommendation systems that just recommend the most relevant item to each user can cause unfairness between items, with some items never or rarely being recommended. On the other hand, algorithms that focus too much on item fairness might impact user performance negatively. The original work investigated this trade-off between the effect that population diversity and user knowledge have on both user fairness and item fairness using a theoretical framework. For the reproduction of the study, the same archive dataset as in the original work was used, consisting of all papers published on arXiv since 1991. The dataset was divided into two. A subset of computer science papers published before 2020 were part of the train set, and a subset of computer science papers published in 2020 were part of the test set, and all other papers were discarded. For both the train and test set, all papers are given a paper embedding based on their title, abstract, and categories. And these are then aggregated and fed into a TF-IDF vectorizer to create their paper embedding. Essential to the research is the utility matrix omega that contains utility values for each author and tested paper pair. And each value in this matrix is the utility of a certain user that a certain user gets when a certain item is recommended to it. Based on this utility matrix, it's up to the recommender framework to find a recommendation policy row, where row I needs to be determined, which denotes the distribution over all available items that can be recommended to user I. For the creation of this recommendation policy, egalitarian fairness is considered. Like you can see here on the slides, with where we want to maximize the minimum user fairness while ensuring at least a portion gamma of the maximal item fairness. The first test in the original paper investigated the effect of item fairness in relation to the diversity within user groups. Their theoretical hypothesis was that in more heterogeneous groups, the cost of item fairness would be lower, as items are already more evenly distributed naturally. The original authors empirically proved this finding, as can be seen in the plots above, which is something we successfully reproduced. So in these plots, where on the x-axis the item fairness constraint is, and on the y-axis the user fairness, you can see that consistently the blue line of heterogeneous user groups is higher than the red line of homogeneous user groups. Then the second test investigated the effect on users for whom no or incorrect preference data were present. Their theoretical hypothesis was that the user fairness of these users would be low, as they would be recommended a generally popular item instead of one that actually fits their interests. Additional item fairness constraints would further worsen this, they argued, as now not only generally popular items are recommended, but all items, including generally unpopular ones. Contrary to their own beliefs, Greenwood et al.'s hypothesis was disproven, as they themselves empirically found that the user fairness for these users was already that low that imposing additional item fairness constraints on them did not further worsen it. This is a finding we also successfully reproduced in the plots below, where, as you can see, the lower lines, the quite straight lines, are the ones of the misestimated users, and you can see when increasing item fairness, the user fairness actually does not decrease anymore. To investigate the generalizability of these findings to a domain beyond a niche academic context, We extended the original research by performing the same tests on a novel dataset about books on Amazon that got at least one review since 1996. We considered all books published before 2007 as part of the train set, and all books from 2007 until the end of 2011 as part of the test set. Just as before, all books are given an embedding based on their title, description, and category by feeding this aggregated data to a TF-IDF vectorizer. All remaining steps are analogous to the approach in the original paper. The results of both our empirical tests show a similar trend to the results of our reproduction. As you can see here, all plots look quite similar. Now, while in our observations, homogeneous user groups are still impacted more by item fairness constraints than heterogeneous groups. So you can see that the red lines here on the above plots are still consistently lower than the heterogeneous blue lines. It is noticeable that this negative impact seems smaller on the Amazon dataset. By plotting all books and papers of the two datasets in a scatter plot using PCA, we found that the heterogeneous users of the Amazon dataset in fact are more homogeneous than the original dataset, which could explain this observation of both lines being closer together in the plot above. Now, all results considered so far only considered a single recommendation for each user. Therefore, a second way we extended the original research is by investigating the effect of item fairness constraints on user fairness when multiple items are recommended to each user. For this, we changed the constraint on row I, the distribution of items to recommend to user I. Instead of constraining row I to sum to 1, we generalized the constraint to sum to k. Empirically, we found that this way, row I approaches a k-hot encoded vector, leading to k recommendations per users when sampling. We found that homogeneous user groups still encounter a higher cost than heterogeneous user groups when imposing item fairness constraints. However, with an increased k, the negative impact of item fairness is lowered, as can be seen here on the plots above. This is somewhat expected, as for each user, a larger variety of items are recommended. So the chances also that, well, at least one that it prefers more is included. The negative impact that comes from imposing item fairness is also lowered for misestimated users, as can be seen on the plots below. For a higher k, misestimations are less problematic since more items are recommended. So again, like above, the chances just are that at least one item that it prefers more than it got recommended with only one item is included. Hence, the quite stable lines are a bit higher, so there's less of a cost of imposing item fairness. Now, this was just a brief overview of the reproducibility study we performed. In the full paper, we further detail the theoretical framework of Greenwood et al., on which the original work and our reproduction were based. We elaborate in detail on the steps we took to perform each experiment and discuss in more detail the results we obtained and how they relate to the claims made in the original paper. Lastly, we provide a link to the GitHub containing the code we used for each plot and end with a reflection on the reproducibility process of the paper.